How to distinguish electric and magnetic fields. Have you ever wondered how to tell electric fields apart from magnetic fields? These two concepts are fundamental in electrical engineering, and understanding them is key. Let's break it down in a simple way. First, let's look at the basic nature of these fields. An electric field is created around a charged particle, whether it is positive or negative. This field exerts a force on other charges within its vicinity. On the other hand, a magnetic field forms around magnets or moving electric charges. It becomes noticeable when you have magnetic poles or electric currents. Next, consider the sources of these fields. Electric fields come from electric charges. You can have positive charges or negative charges, and they create a field around them. Magnetic fields, however, originate from magnetic poles, which are always in pairs, or from moving electric charges. It is important to note that magnetic monopoles do not exist. The lines of a magnetic field always loop back on themselves. Now let's talk about field lines. Electric field lines start from positive charges and end at negative charges. They do not loop back. In contrast, magnetic field lines create continuous loops, starting from the North Pole of a magnet and returning to the South Pole. When it comes to measurement, electric fields are quantified in volts per meter or newtons per coulomb. You can measure them using an electrometer. Magnetic fields are measured in Teslas or Gauss, and a magnetometer is used for this purpose. The behavior of these fields with charges is also different. Electric fields can exert forces on both static and moving charges. Depending on the charge type, they can attract or repel. Magnetic fields only act on moving charges, creating forces that are perpendicular to both the charge's movement and the magnetic field itself. This is known as the Lorentz force. These fields are interdependent. A changing electric field can create a magnetic field, and vice versa. This relationship is described by Maxwell's equations, which are fundamental in electromagnetism. For instance, in antennas, oscillating electric fields generate magnetic fields, allowing electromagnetic waves to travel. In practical applications, electric fields are essential in devices like capacitors, where energy is stored between plates. Magnetic fields play a vital role in inductors, transformers, and electric motors. These devices relying on changing magnetic fields to induce electric currents or forces. Lastly, in electromagnetic waves, electric and magnetic fields are oriented at right angles to each other and to the direction the wave travels. In summary, electric fields arise from charges and affect other charges, while magnetic fields come from magnetic poles or moving charges and only influence moving charges. Understanding these differences is fundamental to grasping the principles of electrical engineering and electromagnetism.